Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Twice as Nice by Not Very Neat, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Now, we have arrows, where digits along an arrow sum to the number in the attached circle. So, for example, if we had, say, a 3 and a 5 here, this would add up to 8, because the digits in the circle, the digits in the arrow must sum up to the digit that's in the attached circle. So that's an example of how arrows work. And we have crop key dots, where digits separated by a black dot are in a 1-to-2 ratio, and we have a lot of them, but not all dots are necessarily given. That's why this is the twice as nice, because these are in a 1-to-2 ratio, and one digit is twice the other. So, for example, if we had a 2 here, this would have to be 1 or 4 to maintain a 1-to-2 ratio between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. What I notice is these circles in the central box are in, well, actually not just them, but a lot of them are in the central box, but they are in a 1-to-2 ratio with a single digit. And that digit is in adding up with another digit with a single other digit to add up to the digit that it is in a 1-to-2 ratio with. Well, obviously, the digits on the arrow must sum to the digit in the circle, so the digit on the arrow is the smaller of the two digits. And this digit in the circle has to be in a 1-to-2 ratio with the digit that it's next to with the black crop key dot. So these are all digits that are twice another digit. Well, the only possibilities for that is 2, 4, 6, and 8. So this must be a 2, 4, 6, 8, and the digit that they are in a 1-to-2 ratio with must be 1, 2, 3, and 4. Well, because we have 2, 4, 6, 8 already accounted for in the central box, we cannot have another 2, 4, 6, or 8 in that box. So this must then be 1 and 3, which is in a 1-to-2 ratio with 2 and 6. That leaves this as 4 and 8 and 4 and 8, which is in a 1-to-2 ratio with 2 and 4. So these are the same digit. These are the same digit. These have to be the same digit, and these must be the same digit. Okay. Well, because of the 1, 2, 3, 4, 6, 8, or the 1, 3 pair, the 2, 6 pair, and the 4, 8 pair, in the central box, the rest of the digits in this box must be 5, 7, or 9. Okay. This digit, we'll mark this as orange, and then this is the same digit to add up to that digit there. And these will mark as yellow. These must be the same digit because, again, this is a sum in a 1-to-2 ratio with that digit, so this digit equals that digit times 2. And since this digit plus that digit equals that digit, these two digits must be the same digit. Okay. We have these scenarios here, which are in similar situations, which are in 1-to-2 ratios with a digit that's on the arrow, which sums up with those digits there. So these two digits must be the same. We'll mark those as green. And these two digits must be the same. We'll mark that as pink. This pink cannot be here or here. And it cannot be the yellow digit. So what digit can it be that it's doubled in? That is doubled in this digit? Well, since these are the same, it cannot be orange, cannot be blue, and cannot be yellow. So it must be the same as light. That it's doubled in. Because again, the only combinations of digits which are doubled and add up to another digit are these orange, blue, yellow, and light. And they have to be different because these are different numbers that are double of those values. So this must be the same as that, which means these two are the same digit. And we have something similar here. This green cannot be the same as yellow, cannot be the same as light, and can't be the same as orange. So it must be the same as blue then here. So this will make that green, we'll make that, maybe we'll make this one pink right now. We'll make that orange. So adding up to, with being double of blue is orange, so that's orange. Being double of light is green, so that must be green. So these two digits, we are not sure. They have to be somewhere here or here. Okay. Well, blue is in a 1-to-2 ratio with another digit here, so that has to be the orange. And this digit is the sum of two unique digits, at least. 2 cannot be the sum of two unique digits. So the orange must be 6. The blue must be 3. The green is 2. And the lights are 1. So this must be either 1, 5 or 2, 4, adding up to 6 here. No 1 here, no 2 here. Since there's no 1 here, this can't be 5. Since there's no 2 here, this can't be 4. 2 eliminates 2 here, so the yellow is now 4. And the pink has to be 2. So 2 and 2 add up to 4. 4 and 4 add up to 8. 2 is in a 1-to-2 ratio with 1 and 4, but this can't be 1 because of 1 in the row, so this is 4 there. 2 eliminates 2 here, so this is 5 and 1, adding up to 6. 5 eliminates 5 in the rest of this row. This is in a 1-to-2 ratio, and it cannot contain a 6, and it cannot have a 4 because of 6 in the column and 4 in the box. That means the only possibilities now are 1 and 2 as a pair. And this can't be 1 because of 1 in the row. So this must be 2 here, which makes that 1 there. Again, this can't be 1 or 2 or 4 to be in a 1-to-2 ratio. That means it has to be 3 and 6 because 1, 2, 2, 4, and 4, 8 are eliminated. So this can't be 3 because of 3 in the row. So this is 6, which makes that 3. Where is 4 in column 5? Cannot be here because of 4 in the box, so it has to be here. So that's 4, which makes this an 8. We have 4 and something add up to something. Well, this can't be 1, 2, 4, or 5. And 4 and 6 adds up to a non-digit, so this can't be 4 or 6. It has to be 4 and 3. Adding up to 7. These are in a 1-to-2 ratio without 2 and without 4. That eliminates 1, 2, 2, 4, and 4, 8. So this must be a 3, 6 pair. And this can't be 3 because of 3 in the column. So that's 6 and that's 3. Remaining digits here add up to a digit here. One of these has to be a 1 because 1 can't be in this box of any of these cells here. And we don't have 2, 3, or 4 available. So 1 and 5 add up to 6, but we already have a 6 in the box. You can't have 1 and 6 because of 6 in the box, so it could be 1 and 7 add up to 8. Or 1 and 8 add up to 9. Either way, we are guaranteed an 8 is one of these 3 cells. Okay. 1 has to be one of these 2 cells, which means in row 1, where is the 1? Can't be here because of the 1's guaranteed in the boxes. Can't be here because of 1's in the column, so 1 has to be there. 1 has to be one of these 2 in row 6. 2 in row 6. 2 cannot be here because 2 is in the boxes. 2 can't be here because of 2 in the column, so 2 is one of those 2. In column 9, 2 can't be here because of 2's in the boxes. It can't be here because of 2's in the rows, so 2 is there. 2 must be one of these 2. And we don't have enough information about the rest. 3. Where is 3 in row 5? Cannot be here because of 3 in the boxes. Can't be here because of 3 in the column, so 3 has to be here. This can no longer be 2, because if this is 2 and that's 3, this adds up to 5, but we already have a 5 in the box. So 2 has to be here. These 2 digits add up to that digit. We don't have 1, 2, or 5 available, and this can't be 6 because of 6 in the column. So if we try to have 3, 7 here, that adds up to 10. So this must be 3, 4, adding up to 7 here. Okay, that eliminates 7 in the rest of the row, so no 7 here. It's 9. This can't be 9 or 7 because of 9 in the box and 7 in the row, so that's 5, which makes that a 7. Okay. Where is 2 in column 1? It cannot be here because of 2 in the boxes, can't be here because of 2 in the row. It cannot be here because 2 cannot be the sum of 2 unique digits that are not 0. So it has to be here. So this is 2. That eliminates 2 in the rest of the row. So 2 has to be there. That should give us all the 2's, right? Yeah. And this digit is equal to that digit plus 2. We don't have 1, 2, 3 available. 4 and 2 add up to 6, but we already have a 6 in the box. 5 and 2 add up to 7. And this cannot be 6 or 7 because of 6 or 7 in the column. 8 and 2 would add up to 10. So this must be 5 and 2 adding up to 7. 7 eliminates 7 in the rest of the row. So this becomes a 1, 8 pair. Adding up with 1 and 8 to add up to 9. Okay. We have 8 3's. We know where the last 3 has to be. It has to be there. These 2 digits cannot be 1, 2, or 3. So at minimum, they are 4 and 5, which adds up to the maximum this cell can be, which is a 9. So this has to be 4 and 5 here, adding up to a single digit. 4 eliminates 4 here, so it's 5 and 4, which forces this to be 9. Column 9, we have 1 and 8 available, but this can't be 8 because of 8 in the row, so that's 1, which makes this 8, which makes that 1. We have all the 1's now. We should have all the 2's. I think we have all the 3's, 4's. I don't know. Column 2, where's the 4? Can't be here because of 4 in the boxes, so it's there. That gives us 8 4's. We know where the last 4 has to be. It's there. 5. 5 in column 3 cannot be here because of 5 in the boxes. Can't be here because of 5 in the row, so 5 is there. We don't have enough information about... Well, row 2. 5 can't be here because of 5 in the box, so 5 has to be there. 5 in column 8, then, cannot be here because of 5 in the box, can't be here because of 5's in the rows, and these are filled, so 5 has to be there. But we don't have enough information to disambiguate for the other 2 boxes. 6 in column 3 cannot be here or here because of 6 in the box. Can't be here because of 6 in the row, so 6 is there. In this lower right-hand box, cannot be here because of 6 in the row, so this is the only one left. In row 9, cannot be here because of 6 in the box, so it must be here. And that gives us 8 6's. We know where the last 6 is. It's there. 7. 7 in column 3 cannot be here because of 7 in the box, so it's there. In this upper right-hand box, 7 has to be there. And we don't have enough information to disambiguate the rest. Well, okay, column 8, 7 has to be here because 7 can't be here because 7 in the box. And we can't disambiguate. 8. 8 in this left central box cannot be here, so it must be here. Cannot be here in this right central box, so it must be there. In column 7, it must be here. And we can't really disambiguate from anything. Yeah, we can't disambiguate from anything else. So then 9s. 9 in row 2 has to be there. In row 5 has to be there. In row 7 has to be there. In row 6 has to be there. And that means in row 9 cannot be here because of 9 in the column, so 9 is there. We have 8 9s. We know where the last 9 has to be. It's there. Okay. So now 5s in row 3 cannot be here because 5 in the box, so 5 is there. That disambiguates the 5 there, so this is 5. 6s. We have all the 6s already anyways. 7s. We're disambiguated in row 8 now, so this is 7, which means 7 in, we have 8 7s. We know where the last 7 has to be, and the last digits are 8. Oops, that's not 8. This is 8. And that's the solution. Pretty cool, actually. I really enjoyed these, using this logic to figure out that these had to be disambiguated. That was very cool. Nice little break-in. And everything flowed very well throughout. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.